So when we look at this, we're going to solve quadratics by factoring. Remember, factoring is using your backwards box, your AC. So in order to do this, a quadratic equation, I'm going to abbreviate that, is a polynomial with a degree of 2, right? We know it's a quadratic because it's got a squared. And it is written in the format ax squared plus bx plus c equals, we want it equal to 0 if we're looking for the roots. Normally it's equal to y. And when we do that, when we put the 0 in place of the y, that just means that we're looking for that x-intercept. Like linear equations, quadratic equations can be solved to determine the value or the values of x that make the equation true. We're going to use some real-world examples below to see that. So it says, Isaiah punts a football, and the path of the ball is represented by the equation y equals negative 1/10 x squared plus 4x, and x is the horizontal distance and y is the height of the ball. So we're going to look at this graph, and we're going to decide how many yards the ball is from Isaiah when it hits the ground. We talked about this in the last unit. When it hits the ground is when it is the what? What are we looking for if it's on the ground? The rocks, right? The x-intercept, the root, the solution, and the 0. So when, looking at this graph right here, when is the ball on the ground? At x equals what?
0, 0, and 40, 0.
At 0 and x equals 40. Okay? So what we're going to focus on today is another way to find those, especially when we don't have a graph. Okay? We would set y, the height of the ball, equal to 0 because when we look at both of these coordinates, the y is in fact 0. Okay? Just when you put that in Desmos, again, don't set it equal to 0 because it won't do it for you. And then we're going to substitute our solutions to make sure they're true. So we're going to set this equal to 0, and this is where you need your calculator. So we said x equals 0. So we're going to actually solve this twice. We're going to say 0 equals negative 1/10. Instead of x, I'm using 0 squared plus 4 times 0. See what you get? I would use my yellow calculator to get a true-false statement for that. And then after we do that one, we'll plug in the 40. I'm going to write that in a different color. So 0 equals negative 1/10, 40 squared plus 4 times 40. So when we put this in the yellow calculator, both of these were true, meaning we did this correctly. So we've done that since, 6th, 7th, 8th grade, where we find out what x is, we plug it in, we make sure it is true. What are some of the limitations in solving an equation with a graph? And think about what we did in our warm-up today, right? If it's on a graph like this, it's really easy to see. But on our warm-up, what did we notice about the roots?
They were not on a point.
They were not exact points. They were fractions. We could have guesstimated it to be 1/3 or 1/5 or 3/2 or 5/3. So some of the limitations in using a graph is the rocks are not always integers, meaning they're not nice, pretty, positive and negative numbers, right? Whole numbers. So a way around that is going to be one of the methods we're going to look at today, and we'll look at some more methods this week as well. So if a polynomial is factorable, then we can use factors, right, backwards box, to get these answers. So we need to always make sure that we are in ax squared plus bx plus c equals 0 format, right? That's our standard form. And we're going to factor our polynomial. And you guys preferred using the backward box, okay? And that was when we did, a times c, and we made our little t chart to get b. We looked at our signs. We're gonna, after we get our factors, then we're gonna set each factor equal to 0, and we're gonna solve it. So if A times B equals 0, then either A equals 0 or B equals 0. We'll look at that a little bit more. And then we're gonna solve for X. So we're gonna take you through these steps. The beginning step with the factoring, you've done. Okay, you guys did really, really well actually on that unit. So let's go ahead and try one. Make your box. If you need to use the space at the bottom, then do that, or you can use the back if you need more space. So we need to draw our box. I wouldn't draw it like ginormous because we gotta have some space. And we know that this is x squared and this is minus 10. And we talked about way back when we did this, look at the sign of C. It is negative. What does that mean about my signs in my box? Same or different? These are gonna be, yeah, these are gonna be different. So if you wanted to make a positive and a negative, you could. And then this is where we write our factors, right? A times C. So my A is 1, my C is 10. So I need to list all my factors of 10. Well, there's not that many, are there? 1 times 10 and 2 times 5, and I need 3. So which of these subtracts to give me 3? 2 and the 5. Now, it is a positive 3. Remember, signs are super important. So which one is going to be a positive if we want a positive 3? The 5. Okay, because we want to have more positives. So now that we have our box filled in, this is where we were taking our GCFs, right? Or in this case, x squared. What's the only thing that makes x squared? X times x. And then we're saying something times x is 5x. What's going to go there? Positive 5. And something times x is negative 2x. Minus 2. So our factors are x plus 5 and x minus 2. Our step says, after we get our factors, it says we factored them and we are going to use a 0. So we're just going to set those factors equal to 0. That's what it's saying. So I want to show you what that looks like. Don't overthink this. It's not hard. We're going to say x plus 5 equals 0. And we're going to say x minus 2 equals 0. Bless you. And now we're just going to solve for x. Well, if I have x plus 5 equals 0, how do I get x by itself? What do I do? This is 6th grade. We're going to subtract the 5. So x equals negative 5. What about x minus 2? It's going to be a positive 2. So really all we're doing is changing the signs, right? So what this is saying that, and we'll graph it to double check it, this is saying that our rocks, if we were to graph x squared plus 3x minus 10, we would have a root at negative 5 and a root at positive 2. So on 4, we're going to do our box. And I'm going to be real honest with you. When A is 1, guys, we really don't even need to do the box. I want you to think about this. We're going to do A times C. So 1 times 12 is what? 12. What are my factors of 12? 1 and 12, 2 and 6,
3 and 4.
3 and 4. I need 7. Which of those gives me 7? 3 and 4. Hey, guess what my factors are? X plus 3 and x plus 4.
So it's going to be x equals
That's when A is 1, okay? It's a lot easier. Now, if A is bigger than 1, then yeah, you're going to need to do the box because now you're doing more GCFs, okay? What are the roots here? If we solve these for 0, what do we get?
negative 3, negative 4.
X equals negative 3 and negative 4. Another way you can do this is you could go ahead and you could graph your equation, which they're going to actually kind of show us on the back a little bit. You could just graph it, and that would give you the roots. You could also work backwards when you do that to get the factors. Sometimes they're going to say, what are the factors of this? If you don't want to do the box, then you could graph this. So let's take a minute. I want you to graph number 3 in Desmos. When we graph this, we got 0, 0, and -3, 0. These are your roots. Guys, we're only worried about the x values. If they gave us this and they asked us about the factors, guys, we're just setting these equal to 0. Right? Because that's what our x's are. If we wanted factors, then we need to move everything to the same side. Well, this one, it doesn't matter because x is x. But what happens when I move this over? What does my factor become? X plus 3. So my factors for this would be x times x plus 3. So you can take your roots and you can work backwards to get your factors because sometimes they do ask you that. Or you take your factors and you find your roots if you're using your box. Okay? On the back is why it's important to do the factoring. Okay? This is kind of like the one we did for our warm-up. They give us the equation and they give us the graph. But notice that these are not nice, pretty coordinates. Okay? When we zoom in, there is 1, so that's nice. But this one, I mean, we could guesstimate it. We know this is definitely 3. What do you think that one is?
-1.
-1.5. We could, okay, let's write it as an estimate. Maybe it's -1 1/3. Maybe it's -1 2/3. Who knows? Okay, so this is where factoring is going to actually be helpful. Now, they did give us the equation, so even easier would be graph it in Desmos. We've looked at our graph. We've estimated. We're going to say we think we're going to use squiggle equals here. -1.5 and 3. So in this case, using the box would be necessary, especially since a is not 1. Okay? 2x squared minus 9. A times c is 18. 1 and 18. 2 and 9. 3 and 6, and we need 3. So which one is it? 3 and 6. Which one's positive? Which one's negative?
Negative is 3.
Is it a positive 6 or a -3 or a positive? -6. -6, positive 3. So the GCF on 2 and 6, this one is going to be your 2x. This is going to be your x. Plus 3, and then 2x times -3 is -6x. That's just box like we've done. So then to verify, we're going to take those and we're just going to set them equal to 0. So x minus 3 equals 0. So x is 3. We already got that one. And then 2x plus 3. All right, so you got a couple more steps, but they're not hard steps. You've done this. 2x equals -3 divided by 2, -3 over 2, which is in fact the -1/2. But you could verify it that way. Okay. Those are the things that you need to be sure about, especially when it's not nice and pretty. Rakisha found the factors of the quadratic. So they're already giving you the factors. What does this mean about the zeros or the rocks? Well, what do? How do we go from factors to roots? We set them equal to what? Set them equal to 0. Well, if x plus 3 equals 0, what is x?
X equals -3.
-3. If x minus 5 equals 0, what's x? X equals 5. So really all we're doing, especially when a is 1, we're just changing those signs, guys. Okay? When we come back from lunch, we're going to look at some that are a little more complex. Sometimes our equations are not nice and pretty. So if it is not already set equal to 0, we need to set the equation equal to 0 because, again, we're saying y is 0, so we're looking for the root. And then we can do our factoring. So for number 7 and number 8, I'm just going to show you the setup on 7. We'll actually solve 8. You would need to move this 14 over. So you can do your x squared plus 5x minus 14, and then you could do your box and write your factors. Okay, but you are not going to be able to factor this until you set it equal to 0. So if you have any extra numbers on the side, you need to move all of them to the same side. So we're actually going to do number 8 because that one, A is not 1. So to move this 5 over, we're going to have to add it. 2x squared plus 11x plus 5. And then we're going to have to do our box. And again, there's some space there, so if you need to use the back, you can. The reason I wanted to work this one is because it is, in fact, A is not 1, right? C is positive, so the signs are going to be the same for both of our numbers. Happens to match B. So 2 times 5, A times C. 2 times 5 is 10. So obviously we have 1 and 10. And then you can start taking out your GCF. So between 2x squared and 10x is 2x. So we're left with x. X times 1 is 1x. 2 times 5 is 5x. And then you can take those factors and you can set them equal to 0. So you get x is negative 5. And then make sure you put a negative when you move that over. And then x is also negative 1/2 or negative 0.5. So if we graphed it, that's what our roots would be. She asked her students to find the zeros of the function y equals x squared minus 225. Georgia claims the function will only have 1 0 at 15. Do you agree or disagree? So if you recall, this is one of our special cases where this is a perfect square and this is a perfect square. Do you remember us doing this? So the square root of x squared is just x. Now, this is a minus, so that means we have different signs. What is the square root of 225? We would have a positive 15 and a negative 15 because our b is 0. So when we set those equal to 0, we get x equals a positive 15 and a negative 15. I wrote those in opposite order. This one would go here and this one would be with this one. So is she right? No. Okay. It is going to have 2 roots, 15 and negative 15. Sometimes you will see this written plus or minus 15 like this. This is the same thing. It's just they wrote the 15 once, so you just have 2 symbols. All right, last one. Farmer Dan uses a sprinkler that follows a path shaped like a parabola. There's our equation. Y is the height, and x is the horizontal distance for the water. Use this to find the horizontal distance the sprinkler covers. So again, if x is the horizontal distance, then they're looking for the root. The x-intercept is 0. What do you notice on this one? Is there a GCF? There's not? Yes, there is. What is it? I'm going to tell you it's actually negative 0.05x. So when you do that and you're left with x minus 120. Okay, if you did a GCF on 0.05 and 6, it's going to tell you 0.05. And then when you divide 6 by 0.05, you get 120. So if we set both of these equal to 0, well, how do we solve this first one? We add, subtract, multiply, or divide? what times 0.05 is 0?
Plus 0.05.
It's just 0, right? Anything divided by 0, right? 0 divided by 0.05, okay, is 0. And then if we have x minus 120 equals 0, x equals what? X equals 120. Find the horizontal distance that the sprinkler covers. Well, does it cover 0 feet or does it cover 120 feet? 120. So you have to think about the distance of that sprinkler.